x to the 5th plus square root of 25x.
That works because they're both, well, I guess it wouldn't work.
It would work because these aren't irrational numbers.
Because
This is,
they can simplify to 4 and 5.
Yeah. Technically, I've got 2 polynomials here. Actually, technically, I've got 4 polynomials here. All the combinations of plus or minus 5. And plus or minus 4. Yeah, but for square root of 5, that doesn't work. Here's like your ultimate non-polynomial. I'll just write a monomial term. Y equals pi x to the negative 4th. What are the 2 reasons why that's not a polynomial?
It's irrational. Pi and the negative. It's an irrational coefficient.
Irrational coefficient, negative exponent. Not a polynomial. Okay, I have to give you 4 first rules of polynomials in 10 minutes. I can do it.
Oh, I thought you were going to say 4 minutes.
I can do it. All right. Start erasing over here. So my cinematographer needs to follow me back over here.
Okay.
I think you should follow, I think you should finish that problem.
That one that I started at, yeah. I'm sure you'd like that.
Well, I wouldn't. I don't think 3 is 9.
Okay. Now, this is... Okay. So what polynomials wind up looking like? General form of a polynomial looks something like this. Y equals some number, which I'm going to call a sub 1, times x raised to the nth power. Okay? And this is what happens when you put a polynomial in standard form.
Okay, why is the 1 a comma?
Pardon? Okay, here's why. That's a 1. That's called a subscript. And you use a subscript if you want to use the same letter over and over again, but have it mean something different all the time. So this would be, if this is a monomial, it might end here. If this is a binomial, my next one might be a sub 2, which is a different number, to the x. And if you're writing a polynomial in standard form, then you write it from the highest exponent and you keep going down. So this one might be n minus 1. If this is x to the 5th, this would be x to the 4th.
I thought you can't do negative. Oh, wait.
Oh, well, if n equals 5, then this isn't a negative exponent.
All right,
N minus 1 will be positive still. And then plus some other number times x to the n minus 2 plus dot, 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 until you get near the end, and you've just got what I'm going to call a sub n, which is the last number. Okay? So you've got different coefficients. And the reason why I'm writing it like this is because I want to concentrate on this form. So for example, let me do an example, this might help. I might have y equals 5x to the 5th plus 3x to the 4th minus 12x cubed plus 17x squared minus 5x plus 22. This is a polynomial. It's a long, fun polynomial. It's beyond a trinomial. This is a 1, 2, 3, 4, 5, 6. This would be a septinomial, but after that, we just keep calling them polynomials. Incidentally, it doesn't have to have every one of these terms. It could be missing this, and then it would be a pentanomial. But still, it can jump from 5th to 3rd degree. All right, we're going to look at the first. I'll talk about degree more tomorrow. We're going to look at the first term. The first term tells you the most about the behavior of the polynomial. And I'm going to keep this really non-detailed today. It's going to be really general. All right? But the first term tells you the most about the behavior of the polynomial. So follow me over here, Eliza, and give you some general rules. Okay. I'm going to use this notation, though. I'm going to use the A notation. Thank you. Okay. End behavior. End behavior. We just did parabolas, right? Every parabola we graphed, starting in December, either had the ends going up like that or going down like that, right? Yeah. Those are all the parabolas can do. Okay? That's called end behavior. End behavior means as you go way out to your left and way out to your right, the ends go up. Okay? Certain polynomials all have that end behavior. So here's the rule. If a sub 1 is positive and n, the biggest exponent in the polynomial, is even, then the end behavior is what I call a touchdown.
Wait, the n is even? I don't understand.
N is the exponent. For example, if I have y equals...
The biggest exponent?
Yeah, the biggest exponent. N is the biggest exponent. For example, a parabola, like we just did, y equals x, y equals x squared minus 10x,
Now it's minus 6 plus 9.
plus 26. Thank you. I don't know much about this parabola right now, but I know it looks something like that.
Can't see.
Okay? That's not a coincidence. What's the coefficient understood to be here?
1.
1. Okay? So my a is positive. My biggest coefficient is even, so it's going to look like a touchdown. Okay? Now this can happen with other parabolas. For example, if I have... Let's do a better drawing than this. Come back over here.
I can help out if you need help for another parabola.
Thanks, Nimi. So for example, if I have y equals x to the 4th, actually, say y equals 3x to the 4th, okay? Plus dot, dot, dot.